Betelgeuse, the cosmic time bomb in our stellar backyard. Right now, even as you read these words, a wave of light from the most spectacular cosmic fireworks in human history may be racing toward Earth through the silent void of space. It has already crossed 649 of the 650 light-years separating us from its source. Only 1 light-year remains. 1 year until night turns into day, and a second sun blazes into existence on our night sky. That red supergiant nestled in Orion's shoulder is far more than a bright winter star. It is a cosmic time bomb, one that could detonate at any moment, or may have already exploded 650 years ago, during Europe's 100 Years' War, decades before Columbus set sail for the New World. In the 1370s, deep within Betelgeuse's core, gravity may have already won its final battle, collapsing the stellar heart into an infinitely dense point and unleashing energy capable of outshining an entire galaxy. That wave of fire is hurtling toward us now. We live in a state of suspended anticipation, never knowing whether tomorrow will bring the greatest celestial spectacle in observable cosmic history, or whether it will unfold millennia from now, long after our descendants are gone. But there are signs, strange, unsettling signs. The star has begun behaving erratically, dimming, flaring, pulsating as if in its death throes. Astronomers stay awake through the night, training their telescopes on the hunter's shoulder, desperately trying to decode the convulsions of a dying giant. Because when Betelgeuse finally explodes, it won't be just a dazzling show, it will rewrite our understanding of the cosmos, and our place within it. A name echoing through time. For thousands of years, humans have gazed upon Betelgeuse without knowing what they truly saw. To the ancient Greeks, it marked the shoulder or hand of Orion, the mighty hunter placed among the stars by the gods. Arab astronomers called it Yad al-Jawza, the hand of the central one. Over centuries, through mistranslations and scribal errors, the name morphed into the word we know today, Betelgeuse. Say it aloud. Feel your tongue stumble over its syllables. There's something ancient in it, something alien, like an echo from forgotten civilizations that, like us, once tilted their heads toward the heavens and sought meaning in the flickering lights above. The Chinese included it in the constellation Shen, representing a legendary celestial warrior. Native American tribes wove Orion's bright stars into their mythologies as sacred figures. Every culture that ever looked up noticed this crimson beacon. It was too bright, too vivid to ignore, its reddish hue setting it apart from the cool white and blue stars around it. Those ancients couldn't have known that this very color was a death knell, that they were witnessing the drawn-out final breath of a cosmic titan. A giant on the brink of oblivion. When Renaissance astronomers began systematically cataloging the stars, Betelgeuse was designated Alpha Orionis, Alpha implying it was the brightest in Orion. Yet it often appears dimmer than Rigel, Beta Orionis. Why? Because Betelgeuse is not constant. It breathes. It swells and contracts, brightening and fading in an irregular cosmic rhythm. Ancient observers noted this variability but couldn't explain it, they simply recorded, sometimes it shines fiercely, sometimes it fades. The real breakthrough came in the 19th century with the invention of the spectroscope, an instrument that split starlight into its component colors. When astronomers aimed it at Betelgeuse, they saw something astonishing: absorption lines characteristic of a cold star. Cold by stellar standards, of course, its surface temperature is only about 3,000 degrees Celsius, half that of our Sun's 6,000 degrees Celsius. That's why it glows red, Hot stars shine blue or white, cooler ones radiate red or orange light, just like a flame, whose base is orange while its hottest core burns blue. But the true shock arrived in the early 20th century, when astronomers learned to measure stellar sizes. The results were staggering. Betelgeuse is colossal. If placed at the center of our solar system, its surface would stretch beyond the orbit of Jupiter. Imagine it: Mercury, Venus, Earth, Mars, and even the gas giant Jupiter all swallowed within a single, bloated star. Everything we call home would vanish inside this monster. Such stars are called red supergiants for their immense size, red for their cool, ruddy glow. But behind these calm scientific terms lies a drama. A red supergiant is not stable. It is in agony. These are the death throes of a star that has exhausted its nuclear fuel and is now swelling in a desperate, final attempt to stave off gravitational collapse, even if only for a cosmic instant. Betelgeuse is dying. Right now. On our watch. Though what we see is how it looked 650 years ago. The nuclear inferno within. 20th-century astrophysicists unraveled the inner workings of such stars through equations, computer simulations, and theoretical models. What they discovered was both beautiful and terrifying. Inside Betelgeuse, a thermonuclear war rages. In its core, where pressure and temperature reach unimaginable extremes, hydrogen atoms fuse into helium, releasing colossal energy, just as in our Sun. But the Sun will burn hydrogen for billions of years. Betelgeuse? Its core hydrogen is long gone. When a massive star exhausts hydrogen, it doesn't simply fade. Instead, a new chapter begins. The helium-rich core contracts under its own weight, heating until it ignites helium fusion into carbon and oxygen. Meanwhile, hydrogen continues burning in a shell around the core. The star seems reborn, but at a terrible cost. The energy released is so immense that it blows the outer layers outward, causing the star to swell hundreds of times in size. Think of a balloon being overinflated. The rubber thins, the sphere grows, and the surface cools, which is why Betelgeuse glows red. But this isn't the end. When helium runs out, the cycle repeats. The core contracts again, heats further, and begins fusing carbon into neon, magnesium, silicon. Each stage burns faster and hotter than the last, consuming fuel in years, months, or even days. The star becomes a sprinter who ran a marathon at a steady pace, but now, in the final meters, expends all remaining energy in a final, desperate burst. Today, Betelgeuse likely has a multi-layered, onion-like structure. At its heart, a core of iron and nickel. Around it, a shell fusing silicon into iron. Further out, layers fusing oxygen, carbon, helium. And finally, a vast, diffuse envelope where hydrogen still burns. This onion is unstable. Turbulent convection churns like boiling water. Enormous bubbles of plasma rise from the depths, cool, and sink back down. The entire star shudders, pulsates, and distorts. High-resolution images reveal it isn't even spherical, it bulges in some places, caves in others. This is a dying giant writhing in agony. Why iron is the end? But why does it all stop at iron? Because iron is the ultimate dead end of nuclear fusion. Up to iron, every fusion reaction releases energy, hydrogen, helium, carbon, oxygen, silicon, all the way to iron. But fusing iron into heavier elements consumes energy instead of producing it. Iron is the point of equilibrium, the nuclear ash that cannot be burned. When a massive star's core becomes mostly iron, the thermonuclear furnace shuts down. With no outward pressure from fusion, gravity wins instantly. The core, roughly the size of Earth but 1.5 times the Sun's mass, begins to collapse. Each cubic centimeter weighs tons. Electrons are crushed into protons, forming neutrons. In less than a second, the core implodes from planetary size to a city-sized sphere, a neutron star. If the core is even more massive, collapse continues past that point, forming a black hole. And in that instant of collapse, something extraordinary happens: the core rebounds. Like a spring compressed to its limit, the unimaginable stiffness of neutron matter halts the implosion and sends a titanic shockwave hurtling outward at tens of thousands of kilometers per second. This wave smashes into the star's outer layers, superheating them, tearing them apart, and blasting them into space at hypersonic speeds. At the same time, trillions of neutrinos, ghostly particles born in the core's collapse, stream out, carrying away most of the explosion's energy. They help drive the shock wave outward. The result? A supernova, a cataclysm so bright it can outshine an entire galaxy. And Betelgeuse is only 650 light-years away. In galactic terms, that's our cosmic backyard. What happens when it explodes? Here's how the event will unfold, from the instant of collapse to the moment humanity witnesses it. Neutrinos arrive first. Just hours after core collapse, Earth's neutrino detectors, in Japan, the US, Italy, will register a sudden, overwhelming flood. Normally, these detectors catch a few neutrinos per day. In those moments, they'll register thousands in seconds. The signal will be unmistakable: a supernova is happening, right now, in Orion. Global alert. Automated systems will trigger worldwide astronomical alerts. Every major telescope, optical, radio, X-ray, infrared, will swivel toward Betelgeuse. Astronomers will drop everything. This is the moment they've waited a lifetime for. The light arrives. A few hours after the neutrino burst, the shock wave reaches Betelgeuse's surface, and the star explodes into view. To the naked eye, a new star appears in Orion, brighter than Venus, then brighter than the full moon. Within days, it may even be visible in broad daylight. Night turns to twilight. At peak brightness, Betelgeuse's supernova will cast sharp shadows at night. You'll be able to read a book under its glow. The sky won't be black, it will glow deep indigo, like perpetual twilight. This will last for weeks, even months. Gradual fade. Over the next year, the supernova will slowly dim. After 3 months, it's still visible to the naked eye. After a year, you'll need binoculars. After 5 years, only large telescopes can see it. But what remains is even more remarkable: a glowing nebula, the expanding shell of Betelgeuse's former self, now enriched with newly forged elements like gold, platinum, and uranium. Are we in danger? Many fear a nearby supernova could end life on Earth. But Betelgeuse poses no threat. The danger zone for a supernova is within 100 light-years. Betelgeuse is 650 light-years away, far outside that range. Earth's atmosphere will absorb any harmful radiation. The extra dose will be less than a dental X-ray. What about a gamma-ray burst, GRB? These ultra-focused beams of radiation can sterilize planets, but only if aimed directly at us. Observations confirm Betelgeuse's rotational axis is not pointed at Earth. Any GRB would shoot harmlessly into empty space. So no, this will not be an apocalypse. It will be a cosmic gift, safe, spectacular, and scientifically priceless. The Great Dimming, false alarm or final warning? In late 2019, Betelgeuse began dimming dramatically. By February 2020, it had faded by more than half, visible even to casual stargazers. Was this the prelude to explosion? Astronomers scrambled. Telescopes worldwide locked onto the star. Theories flew: core collapse? Extreme pulsation? A dust cloud? The truth emerged by mid-2020, a massive dust cloud. Betelgeuse had ejected a huge plume of gas, which cooled and condensed into dust that temporarily blocked its light. This was confirmed by infrared observations and high-resolution imaging showing an asymmetric, darkened region on the star's surface. Red supergiants routinely shed mass. Betelgeuse loses the equivalent of 1 Earth mass per year in stellar wind. But this was an unusually large ejection. While not the final death knell, it was a stark reminder: Betelgeuse is unstable, chaotic, and very close to the end. We are star stuff. When Betelgeuse explodes, it won't just destroy, it will create. In the supernova's inferno, temperatures and pressures will be so extreme that elements heavier than iron, gold, silver, iodine, uranium, will be forged in seconds. Every atom of gold in your jewelry, every uranium atom in a reactor, was once born in a dying star's final moments. We are literally made of star stuff. The carbon in your cells, the oxygen in your lungs, the iron in your blood, all were cooked in stellar cores billions of years ago. Betelgeuse's explosion will scatter new atoms into space, some of which may, in a billion years, become part of new planets, and new life. A cultural earthquake. Unlike most astronomical discoveries, which reach the public through news articles, everyone will see this supernova together. No telescope needed. Just step outside and look up. The impact will be global. Children will be inspired to become scientists. Artists will paint it, poets will write of it, philosophers will ponder our cosmic fragility. Social media will explode with images and awe. Religious groups may interpret it as a divine sign. Conspiracy theories will flare, until scientists calmly explain, this is natural. It's safe. It's beautiful. This event will unite humanity in a shared moment of cosmic wonder, an experience not felt since ancient eclipses or comet sightings. The unknown timing, a cosmic suspense. We don't know when it will happen. It could be tomorrow. In 100,000 years. Or it already happened in 1370, and the light is just now arriving. That uncertainty is what makes Betelgeuse so haunting. Every clear winter night, you can look up at Orion and ask, is tonight the night? Astronomers joke that watching Betelgeuse is like waiting for a balloon to pop. You know it will, but you never know when. You might stare for hours, and the moment you look away, pop. Hence the global monitoring networks, robotic telescopes scan Betelgeuse nightly. If it brightens suddenly, alerts will ping scientists' phones worldwide within seconds. Legacy of a giant. Long after the supernova fades, its remnant will remain, a glowing nebula like the Crab Nebula, born from a supernova in 1054 AD. At its heart, either a neutron star, a city-sized object spinning hundreds of times per second, beaming lighthouse-like pulses, called a pulsar, or a black hole. Either way, this object will be studied for centuries. It will anchor textbooks, inspire missions, and perhaps one day, even serve as a destination for interstellar travelers. And through it all, Betelgeuse will teach us a profound truth: death and creation are one. Stars must die so that new stars, planets, and life can be born. Our existence depends on ancient stellar sacrifices. The final night. Imagine this. It's a cold winter evening. A child steps outside to walk the dog. The sky is clear. Orion stands tall. But something's wrong, his shoulder glows too brightly. The child stares. The star grows brighter by the minute. Soon, it outshines every other object in the sky. The child runs inside. Mom. Dad. Come quick, there's a new star. News spreads like wildfire. Phones buzz. Social media erupts. News channels break in: Betelgeuse has exploded. People pour into the streets. Strangers talk to strangers. Families huddle under the sky. Teachers cancel class and lead students outside. This, they say, is where the atoms in your body were made. For weeks, nights are bathed in soft, eerie light. Birds sing at midnight, confused by the false dawn. The world pauses, not in fear, but in awe. And in that moment, humanity remembers. We are small. We are temporary. But we are connected to the universe in the most intimate way possible. Waiting in the dark. So we wait. We look up. We wonder. Betelgeuse still glows its familiar red in Orion's shoulder, for now. But one night, that will change. And when it does, the sky, and perhaps humanity itself, will never be the same.